I got 5 minutes to cover 14.4, so we're going to start it. We may finish it. Well, we will finish it at some point later. Do you have the launch, the plant graph?
Yes.
Graph about plants? So, one thing that I enjoy, I try to incorporate my teaching into like what I actually like. When you grow your own plants, one, it's rewarding because you've grown your own plant. Two, you get free food. And nothing's better than free food. We grew so many tomatoes this past year. It was insane. So, let's say we start a plant club here at Phoenix. What do we notice about friend 1, friend 2, and friend 3 about their plants when they started?
Friend 1 stinks at growing plants.
What do you notice? Maybe friend 1 went on vacation. Huh? They have different starting points. What do you think that means when we actually look at that in the terms of the realistic situation? The plants.
They're different sizes. When they start.
Yeah, so the plants start at different heights. You can buy seeds or you can buy plants already growing. When we are going to very soon be talking about the flower sale, the plant sale. I hate that we call it the flower sale because I buy my tomatoes and peppers and stuff from that. You will get plants already growing, guaranteed to yield whatever it's supposed to. So fruit or vegetables or whatnot. So maybe these friends all bought 3 different plants at 3 different heights. And okay, so you guys said friend 1 is really bad at growing plants. Why?
How can you be bad at growing plants?
If you don't water it, you don't put it in the sun, if you don't put it in the right place, it's not going to be successful.
I just feel so stupid today. Okay.
What do you think friend 2 and 3 might be doing that friend 1 is not?
Paying attention
Yeah,
to the plant.
paying attention to their plant. Now, so forget about friend 1. Friend 1, you're out of here. You don't love plants. Friend 2 and friend 3. Which one do you think is growing better? Olivia?
Friend 3.
Why?
Because their slope is slopier.
All because I like it. Their slope is slopier.
They're gonna intersect here.
All because friend 2's plant is still taller does not mean that their plant is growing better. If we compare these slopes, remember, go point to point. Point to point, my rise is 1, my run is 2. Friend 2 has a slope of 1/2. So every week, their plant is growing 1/2 inch, because that's going to be half for 1 week. So really 1/2 over 1, 1/2 over another 1. Now I'm up at my intersection point. Friend 3, if I go point to point, oh, I'm still writing in red. Point to point at the intersections. My rise is 2, my run is 3. So friend 3's slope is 2/3, bigger than 1/2. Their plant is growing, 2/3 of an inch every week.
Well, if you look at the slopes, like if you were to go like more weeks ahead, friend 3 would jump, and then it would intersect, and friend 3 would go bigger.
So that is, I forget what chapter it is, but we are going to get into where and how do we figure out the intersection points of 2 different lines. So since friend 2 starts higher but has a lesser slope, friend 3 starts lower, has a steeper slope or a slopier slope, we know that at some point they're going to intersect. If I continue this graph out, their lines would intersect, and then friend's 2 plant would be shorter than friend 3's plant.
I wonder if the plants are different.
So what we really want to take from this lesson is the understanding that all your slope is telling you is the unit rate of what's happening. So your slope for those plants, how we just talked about 1/2 inch a week or 2/3 of an inch a week.
A rate
that's
is a
all just discussing per 1x. So your slope is really the y change per 1x. So I don't have a copy of those notes. Hold on. I just only got like 3 minutes, guys.
I just love my binder so much. It warms me up.
So, if you have your notes up, you'll notice that there was a part we did not fill in. So, this plant's unit rate for growth, if we looked at, oh crap, I calculated those wrong because I didn't see that my scale had changed. So actually, on these from the last one, I'm going to delete that slide because that's actually incorrect.
We don't even have that.
Yeah, so you don't have the whole graph. You just have one of the plants. But notice that these are wrong. I'm going to just go ahead and delete that page.
So in the video, it's going to be confusing.
Yeah. Sorry, Jackson.
And
Because
Ashton.
my y values do not go up by 1, they actually go up by 2s. This, instead of being 2/3, was actually 4/3. So we calculated it as 2/3, but it's actually 4/3. So this was 4/3 of an inch per week. So that's what you want to put down there, is that it was 4/3 was my slope, but that is the y per x. Your y per x. So then, if we look at the cheddar cheese graph, how many ounces per gallon? Remember, it's the y per x. Well, I start at 0, 0. That's great because it helps me with my delta y, delta x. What's my delta y here? What's my delta y here to get to that point? 32. And my delta x is 2. So I really get 16. So it's 16 ounces of cheddar cheese per gallon of milk that they use. So it takes a gallon of milk to make 16 ounces, a block of cheese.
Wait, so isn't that a pound?
Well, it depends on, yes, 16 ounces is a pound, but it depends on if you're looking at liquid measurement or weight measurement.
And it's
That's what's bad about using ounces for
But the cheese is a solid though, right?
cheese. So ounces with cheese would be measured in weight.
Right.
So this is 16 weight ounces per liquid gallon of milk. Yeah, that's what's bad about ounces.
And then at the start, it's just milk and then a couple more ingredients to make the cheese.
Yeah.
So it's a liquid at the start and then it turns into a solid.